So the first one we want to look at is we have to calculate the heat energy needed to convert a 2 kilogram of ice at negative 12 degrees Celsius to steam at 100 degrees Celsius. So we are being given the specific heat capacity of water to be 4,200 joules per kilogram per Kelvin. Then the specific heat capacity of ice to be 2,100 joules per kilogram per Kelvin. The latent heat of fusion of ice to be what? 336,000 joules per kilogram per Kelvin. And then our latent heat of vaporization to be what? 2,260,000 joules per kilogram per Kelvin. So let's look at the solution for this example. So let's write down solution. Alright, so let's analyze the question. So we have to calculate the heat energy needed to convert what? A mass of what? 2 kilogram of ice. So we have the mass is what? 2 kilogram of ice at what? Negative 12 degrees Celsius to steam at what? 100 degrees Celsius. Now, when it comes to this, there are a lot of transformations that are occurring over here because we are looking at an ice being converted into a liquid first before we are boiling the liquid or we are heating the liquid into what? The steam or the gaseous state. So there are 3 transformations that are occurring over here, and we need to look at that. I said 3. There are 4 transformations. The first one that we need to take note of is what? We need to change the temperature of the ice from negative 12 degrees Celsius to 0 degrees Celsius. So we change the temperature of ice from what? From negative 12 degrees Celsius to 0 degrees Celsius. And then there will be a heat energy needed to do this conversion. Now the second one is what? The change in state, because we need to change the ice, okay, from solid at what? 0 degrees Celsius to liquid, which is water, at what? 0 degrees Celsius. So we are converting the ice from what? Solid to liquid at the same temperature, but then there is a change in what? State of matter. Now the third one is what? We need to boil the water or subject the water that we now have after the ice has melted. We have to subject it to heat. So we boil the water, okay, from what? 0 degrees Celsius to what? 100 degrees Celsius. Okay, now once we boil the water to 100 degrees Celsius, we can see that the water will begin to what? Change state from what? The liquid state to the vapor state. So we are looking at what? The conversion of what? Water, okay, at what? 100 degrees Celsius to what? Vapor at the same temperature. Alright, so sorry about my ugly handwriting. So let's look at the energies involved in the first case. So the first case, we need to convert the ice from negative 12 degrees Celsius to 0 degrees Celsius. Okay, so the amount of heat energy required in this particular case is equal to the product of mass multiplied the mass of ice, okay, multiplied by the specific heat capacity of ice, multiplied by what? The change in temperature. Alright, so the heat energy over here, let me use that as Q1. The mass of the ice we are given is what? 2. The specific heat capacity of ice is being given to us as 2,100 joules per kilogram per Kelvin. And then the temperature change over here is from what? We know in terms of numbers, we know 0 is bigger than negative 12. So we have the higher temperature, which is 0, then minus then the negative 12 that we have over here. So our heat energy becomes what? 2 multiplied by 2,100 multiplied by this becomes positive. So we have 12. So it means the heat energy needed to convert the ice from 12 degrees Celsius to 0 degrees Celsius is the product of 2 multiplied by 2,100 by 12, and that will give us what? A total sum of heat energy of 50,400 joules. Okay, so this is for the first aspect of the calculation. Now, the second aspect of the calculation is what we have to convert the ice, okay, from the solid state at what 0 degrees Celsius to a liquid state at the same, okay, temperature. So we can see that we are converting from what, solid to liquid, okay, solid to liquid. So it means we are dealing with what, latent heat of fusion, okay, latent heat of fusion. So our second heat energy, latent heat of fusion. So if we have a change in state and we know that that change in state involves the latent heat of fusion, all we need to do is multiply the mass by the latent heat of fusion, and then we get the heat energy in that process. So the mass that we have, okay, is what, 2, then multiplied by the latent heat of fusion of ice is being given to us as what, 33,336,000. So if we do the multiplication, we are going to get 672,000 joules. Okay, so this is the heat energy needed to convert the ice at what, solid state to the liquid state at the same temperature of what, 0 degrees Celsius. Now let's look at the third heat that we need. So we have to convert now we have water, so we have to boil the water from 0 degrees Celsius to 100 degrees Celsius. So the heat energy involved in that process is what, the mass of water multiplied by the specific heat capacity of water multiplied by what, the change in temperature. So the mass of water is still the mass of ice, so we are assuming no matter has been lost during the conversion. So the mass is what, 2 multiplied by the specific heat capacity of water is 4,200 joules. Then multiplied by the change in temperature over here is, we are converting from what, 0 to 100. So the change in temperature is what, 100 minus 0, which is still 100. So if we do the multiplication over here, we are going to get 840,000 joules as our energy required for this particular third step. So let's look at our fourth energy involved in this particular example. So the fourth one is, we are converting water at 100 degrees Celsius to vapor at the same temperature. Okay, so we are converting from what, liquid to what, to the vapor state, and that is what, latent heat of what, vaporization. Now, from what I said earlier on, the latent heat of vaporization, if you want to know the amount of heat involved, is just the product of the mass of the substance multiplied by the latent heat of vaporization. So it means we multiply the mass of 2 by the latent heat of vaporization, which is 2,260,000. Okay, and so the heat energy in this process, that is converting the water from 100 degrees Celsius to vapor at 100 degrees Celsius, becomes what, we have 4,520,000 joules. All right, so now that we've calculated all our energies needed for the conversion, let's sum all our energies to get our total energy needed to convert the ice from negative 12 degrees Celsius to what, 100 degrees Celsius, that is vapor at 100 degrees Celsius. So our final, or our total energy, is the sum of what, all the individual energies needed for the 4 processes. Okay, so we have the sum of what, 5,400 plus 672,000 plus 840,000 plus 4,520,000. So our total heat, let me use blue for that. So our total heat energy needed for this conversion is what, 6,082,400 joules of energy. So this is the amount of energy we need to convert a 2 kilogram of ice at what, negative 12 degrees Celsius to what, steam at what, 100 degrees Celsius.